So Sefas mentioned it, but you can check out Compliance Detective. So what we are trying to do there is distill privacy engineering, AI governance, and advanced data protection topics for non-technical folks to start building some bridges with cybersecurity teams and legals, or like product teams and data science teams and security. So we're trying to bring this interdisciplinary community and content out there so that people have the basic literacy at least to discuss these topics among their teams and organizations. So everything we do this on the privacy and creativity space. So that we started with a comic book. So you can scan the QR code. So it would be relevant to today's topics as well, if you want to like catch on. So this is like a comic book that teaches privacy engineering for non-technical folks, just to emphasize that. We're doing events, and last year we did the whole festival around AI governance and privacy on Data Privacy Day, 28th of January. Also, all the participants are welcomed to join this year's festival as well. And this is like the overlook of games, so you can again scan the QR code to access to the games as well. Um, Everything that we're going to be talking today regarding like what is privacy engineering, data flow diagrams, privacy threat modeling. There's a game that you could also play after this event to, yeah. In a nutshell, what we are trying to do as privacy engineer is bring the fundamental data protection principles out there into implementable controls and frameworks that we could concretely show that we have implemented them in order to abide by the accountability principles as well. So basically, the problem we have with data protection laws, usually like terms like state of art or like automated decision making and profiling, etc. These among the legal world have lots of meanings, and in order to like really make these um, baked into our product design and services, we need the engineer's perspective of how these legal concepts will be implemented in the products. And that's what exactly privacy engineers do. So what are the skills that we need in order to like become a privacy engineer, or one could ever become a privacy engineer, or like is it more like a student of life kind of discipline? And again, I'm gonna just like hopelessly try to get one of you guys engaged. Any ideas of like what privacy engineers should know? Should they know legal and be like lawyers in backgrounds? Should they know data science and know like statistical data closures, or cybersecurity or compliance and GRC? Any ideas? Again, a 5-second opportunity. All right, so actually, if you scan, you'll get the answer. So it's like a really broad set of disciplines. If you scan the QR code, you could also get to this chapter. It explains what privacy engineer is. And again, it takes you to this spreadsheet. Basically, I called it like skills map. What skills a privacy engineer should have um, in order to holistically provide every discipline and perspective to make a product, an AI system, a software as a service platform, or whatever um, privacy by design principles accomplished. So there's something in the chat. Oh, all right. There were answers in the chat. That will do as well. Thank you, Agatha, for the input. And I don't know, like if you can see, but it's not important. I just want you to like skim through it. You could again scan and take a look in your own devices. But there are soft skills that we need to have. There are compliance skill sets around regulations, frameworks like ISO, NIST, or technical skill sets. This might be like Agatha said, computer science, security, data science, um, cryptography, etc. And one could learn all of them, Well, that's a challenge, and that's a challenge I've been trying to like implement as a lawyer. My again mission is to prove that also lawyers can be in the same table as privacy engineers. So like I'm saying, I'm a privacy lawyer aspired to be a privacy engineer because I know I don't have all these skills, but at least slowly but surely I get in a, how can I say, like I get literate in all these styles and what they mean, and be able to talk at least and understand what the other discipline is talking about, whether be it usable privacy, where you talk with UI, UX guys, etc., or the security guys on how to isolate networks, or like secure the database and provide like non-linkability in the systems, etc. So at least get this would give you a bigger picture around like how holistic discipline privacy engineering is. And we see this the same concept. So I haven't published that yet, but it's almost done. um, we're doing the same version of this for AI governance perspective, and the same problems. So like they already like have lots of intersecting skills in place, a privacy engineer and an AI governance expert. But again, there you'll see even much more broader disciplines getting involved uh, on making a system privacy by design plus um, abiding the responsible AI principles. So yeah, in technical skills, just like again, we could go through this. So in soft skills, communication is the king, the crown jewel of the skills of a privacy engineer. So you need to communicate really well, write really well, and make sure you listen really well, because always the devil is in the details, and like we really act as like detectives. That's why I chose the name compliance detective. So like we're really cyber detectives trying to solve what's going on in the systems, not legally, but holistically with the systems, data flows, third party risk management, etc. So there are lots of problems to be solved, lots of mysteries to be uncovered in order to make legal and engineering decisions. And therefore communication is key. um, you should be able to understand the basic principles in laws like GDPR, CCPA, and all the international frameworks like ISO 27000, ISO 42000 series, etc., where like there's a governance mechanism and framework that are built. So like you don't have to discover everything anew. You can use the existing frameworks, which like privacy engineering is trying to be defined for starting from 2000s, right? So there's a big knowledge and best practices and case studies that you could take and implement in your own privacy engineering journey or your new AI governance journey as well. So yeah, in technical skills, again, familiarity with SQL, Python, other scripting languages might help, at least understanding what the code means. If you don't like coding, so like I know there are lawyers here who like don't have the time to learn coding, then I urge you to use tools like Bubble, Webflow, where you could build a no-code platform, but at least get an understanding of how to set up a database, what the front end is, what the back end is, how do they communicate with each other, etc., etc. So um, understanding system architecture is one of the most important skills, because in order to diagnose something, you need to understand what you're looking at, right? So now, like after this, actually, I don't want to lose too much time. I'm just gonna like mention the certificates. There are global organizations like ISACA, IEPP, etc., that provides like industry-wide recognized certifications. So you could check them out in order to get some like uh, yeah, if you want to work for like an enterprise or something. But yeah, I don't want to lose more time here, so I'm just gonna get back to the slides. Again, any questions? Domains like data management can be involved. Yes, Cephas, I just saw that. So we said privacy engineering tries to bring these disciplines into real life and make it concrete, right? So the first question is, in information security, we have a triad, right? The CIA triad: confidentiality, integrity, and availability. I assume everyone knows them in certain levels, so I'm not gonna lose time there. But in privacy engineering, on top of that three, we have three additional requirements that we must fulfill in order to say, all right, we have implemented privacy by design as best as we can, and privacy engineering discipline as best as we can in order to make these rights principles realized. So unlinkability. And yeah, sorry, the text under it are wrong, by the way. But unlinkability is, do we allow our systems to, like, let's say we have Cephas in our database and we use like pseudonyms, either through hashing or tokenization that says Cephas is 123 and dot. So unlinkability means when we're using the Cephas's masked information in like various databases, various processes, um, but do we still know that 123 dot equals to Cephas or not? And especially in scenarios with, like, always keep in mind the contextual in yeah, like, actually wait, let me take it back from there. So what you need to understand is like the privacy problems that we face today. So like, all right, we have sensitive data that are deemed really, really important in all data privacy laws and require certain additional mechanisms in place in order to process them, right? But we share this information with a doctor without any concerns, right? So none of you had a problem with sharing your MRI scans with your brain surgeon if you're getting a brain surgery. But you would be if I opened that and like shared my screen in this current event with all the diagnoses that you have, and we learn it, this 10 people, 5 people, whatever here. So it's important to understand what is the context that data is used. So in unlinkability, and with our current example, with Cephas's pseudonym that we use, if we're able to use that pseudonym in various um, different databases, and this common identifier becomes a privacy threat. And we will talk about what those threats are in the next slides. But like, we don't want to link data because that increases the privacy risk. So in a nutshell, you could just remember this about the principle. And transparency is like really obvious. And we need to provide the information about who we are as data controllers or processors. Why do we collect the information that we collect? How do we process it? What are the purposes? Um, how long we gonna retain it? And if they want to use their rights, like rectification, data access, deletion, portability, we provide an easy to consume way to use their rights and how they could exercise their rights in a nutshell. And intervenability is like the last bit of what I said regarding transparency, giving users control over their personal information via the rights that are, again, entitled by these data protection laws in general. So like, we need to, on top of confidentiality, integrity, and availability, we need to provide these additional triads in the mix so that we could provide the privacy by design system in place. Again, any questions so far, please just like go in. And what do we have in order to abide by these principles? So like, the current existing one that also the legal people use it is DPIAs. So whether certain thresholds are passed with regard to the risk a system might create, we need to be able to show and demonstrate that we have actually um, conceptualized all the problems, all the data protection risks and principles that we must implement, and see what could go wrong and how did we balance our needs in system design and in our commercial actually proportionality. So like, we don't have all the resources, so I can't just as a startup go and build like differential privacy systems all over the place, or keep all my database with like using homomorphic encryption, right? So like there's a big aspect of it, and it's resource management and budget. So like, how do I do this based on the risk, the amount of data I collect, and my business resources? So like that's always in the end, uh, yeah, the bigger picture. So DPIA is something that we do, that the law abides us, the law mandates us to do if we process certain information. For threat modeling, though, what we have is, again, now we're looking at the cybersecurity domain and bring that knowledge as privacy engineers on top of the DPIA process in order to abide, again, the six uh, principles that we're trying to achieve. And what threat modeling does is um, take it much more um, in detail and much more on a technical level, dis decide on what could go wrong with a methodology. So like we use usually Linden, and there are some new emerging ones, but like the most acknowledged one and the ones that we will be talking about is the Linden framework, created by Kimwitz. And what she and her team did was actually take, I'll answer that, Sefas, take the stride, the Microsoft cybersecurity threat modeling methodology, and tweak that into a privacy version, which we call Linden. And again, it uses the same methodology, but for privacy threats out there. So threat modeling is something, again, in order, as privacy engineers, what we do in addition to like the legal folks who conducts DPIAs as well, and which includes also technical information. But again, this would be totally technical documentation that we do in order to spot the risks, make mitigation plans, and yeah, um, use this in our risk management framework, whatever we're using. So Cephas's question, what's the place of privacy risk analysis in privacy by design? So one core principle is like the proactive approach in privacy by design. And what we do in threat modeling is basically that. Without we build the system, we build it conceptually, we put all the components. So like, um, actually, let me go with the order. So I thought it was the next slide. There was a visual. But Sefas, yeah, in order to proactively manage the privacy risks, you need to do threat modeling before you take your system up and running, right? So you need to validate conceptually, then test, and then take it into production, all before releasing the product to the market and let it use real personal data of real data subjects or real users. So the proactivity part uh, is the short answer to this question. So what do we look at though? Like when we're threat modeling, what are the threats that we are assessing the system against? And again, we talked about linkability in general, but to reiterate, linkability threat occurs when we are not able to hide the link between two or more data points. And this might be like an IP address that we see on different databases. This might be an email address, like a unique identifier that we know it could be identifiable as well. But again, the linkability threat occurs when two records are used in different places that we know exist. Identifiability threat occurs when we go one step over linkability, and now that we not only know that two records are linked together, but we can also identify the person behind it. So like linkability, think of it like, again, a pseudonymized, but identifiability, we have like a plain personal information that we could identify now, and we can relate to a real person without looking at any other information. Um, Non-repudiation. So like, again, there's a twist with the STRIDE, the cybersecurity threat modeling terminology, which is a principle. There is repudiation, but in privacy world, we have non-repudiation. And basically, it's something to not be able to deny a claim. So my favorite example is a whistleblower in a evil corp, let's say. Um, So the evil corp is doing something bad, and the whistleblower wants to blow the whistle, but due to bad configuration, the company knows which employee blow the whistle, and the employee gets fired, sued, etc. And that employee, due to the leak on the IP address, and he's become now identifiable, um, can't deny that he wasn't the one that made the um whistleblowing. So this might be an election, a voting. So like you get the point in what it requires to protect. Detectability. So like this is knowing that Cephas is currently at this call without having access to the whole data, but like understanding that a piece of information, a piece of identifiable or linkable information exists um, in a record. So again, an example might be a celebrity has a health record in a rehab facility. So unawareness is being unaware of the consequences of sharing information. So this might be users not knowing that our software as a service platform has like a large language model by a third party integrated, and like everything they do, we share their commercial information, company information, personal information to that system without them knowing. So like again, unawareness is a risk around the transparency part. Non-compliance is again self-evident, but like not abiding the compliance requirements of data protection regulations, internal certifications, frameworks, or whatever the company is measuring their KPIs. All right, I always mention like to be proactive, we need to conceptualize the system before building it, right? And unfortunately, due to again budget constraints and resource constraints, these often go um wrong. And what I mean by wrong is they either stay in the backlogs as a to-do list, but due to like the rush of the business guys, like we need to get this app running by December, and the investor is pushing in or whatever. Um, Usually, we in real life need to do this stuff after the system is up and running. And again, that's not privacy by design. We always want this shifted left as possible within the like whole software development lifecycle, shifting privacy left. There's a saying, and there's an amazing podcast by Deborah Farber on this topic. So how do we conceptualize? How do we map the system? How do we make it visual that legal perspective, engineering perspective, security perspective, product perspective, all can look and talk in the same map of sorts. So this is a data flow diagram, and there are lots of versions and different methodologies of doing it, but it's quite easy. And like once you get to know one, you can understand every one of them. Um, Actually, this is a social network, and of course, it's ridiculous to visualize a social network, which is like one of the most complex softwares ever built, um, in like 4, 5 shapes. But this is like, think of this in layers. So now we're looking at the first layer. Actually, this is called the zero layer. And this is only to understand, all right, what the system does. Then we break down each of these components into sub components that might be like, yeah, today I'm not going to show something like complex, but just know that this has layers, and now we're looking at the easiest, the most high level as there can be. And uh, of sorts where we have like the data APIs and the logic behind it, what we have in like the front end part. Data store is shown by like these two lines, is where we store a database, like in this current example. So like this could be a database, but it also be a physical um, representation of like a file cabinet as well. So a data store is shown like this. The arrows show the data flows, and this bigger rectangle has the trust boundary. So like what we have control over usually is depicted inside a trust boundary, right? So think of this like again, just to spark some ideas. This is your firewall, and these are your components that you have control of inside your firewall. And users are outside of your firewall. Of course, they're using their own clients. This might be a mobile app. This might be a website, browser on a desktop or an iPad, whatever, or a PlayStation even. But again, we use these components to depict the complexest system that could there be existed can be shown within these uh, entities. That's the message. So how do we threat model? So the best way to do it is like for each of the components that we have, we go through all of the threats that we have mentioned here. Remember the privacy threats. And we make an assessment on the system of which of these might be applicable to these. So like one example that we could be saying is linkability of social network data store. So remember this was a database of the social media users. So one problem we might have like Cephas there and 123 dot was the pseudonym that we were using, and using the same in different databases in like third-party app integrations, ads, or like event tracking is increasing the risk of Cephas being identifiable. Identifiability at data flow, which is like this user data stream to user portal. Remember, arrows show the data flows. So now we are talking about this user, Cephas, being identified while he's inputting anything on our website at whatever he's using. So information disclosure of communication between the user and the social network. Again, this might be this social app that we're looking at might be using for training their AI models. And the users of this social media app, Cephas as this external entity, the user might not be aware of his personal information is being used to train the models because like now this social media platform is doing like astrology dating app because yeah, I don't know if that's a thing. That's a thing actually. But um, just understand, so like what we're trying to do is like based on the resources that we have, we could go into deeper layers of this data flow diagrams. But in a nutshell, what we're trying to do is once we are looking at the data flow diagram, we identify the components in that layer. So like here we only have again like 5 things to look at, so it's easy. But when you break it down, it's hard to allocate all the resources, and there's going to be some dedicated people, and usually external consultants charge on an hourly basis. So like this not get done if you don't have like an internal team. But the best practice in privacy engineering is to do it for every component that you see. But based on the resources you have, again, you could go to a higher level, at least in order to get the fundamentals in place. So, of course, identifying the risks, threats is not the end goal here. How do we mitigate them as privacy engineers? That's like the second task. And then the third task is to monitor and review those plans and mitigations that we did really work, or any risk increasing, we need to mitigate them into acceptable level as well. So like it's an ongoing, that's why I said like a student of life, uh, a privacy engineer's journey, I would say. So based on the previous threats that we just mentioned, now let's see how we can solve these problems. And remember the first one we said linkability of social network data store, that we had the same pseudonyms used for Cephas in the social network DB. So we could solve that by using applied data anonymization techniques such as k-anonymity. Yeah, but like this isn't the best practice. It's like outdated. But we could use like, I don't know, order preserved tokenization so that we could still use like the pseudonym in like analytics, sorting, and getting reports. But we do this again in a token and pseudonymized way. The other one was identifiability at data flow of user data stream, right? So like outside a firewall, the user comes to our social app, and how do we control that while he's getting into our system, communicating with us, nothing gets wrong in the way and somebody gets in, or even us don't have the opportunity to make it identifiable. So there we could have like Tor network included here, and that's how we could at least minimize the risk of exposed IP addresses due to onion routing, and use it like a privacy enhancing technology in that data flow. So I know I'm out of my time, so like, but I just want you to get like a basic understanding. So teşekkürler means thank you in Turkish. I hope that Sefas and I will do this in Istanbul physically as well in 2025. So thank you for your time, and hope that actually helped you get an idea of what's going to be included in today's session. So that's it, Sefas.
Thank you, Mark. That was a very nice overview, high-level introduction. So